Hello friends, how are you? In this video clip, I am going to brief you on textile dyes, that is on reactive dyes. We'll discuss this reactive dyes in brief on whiteboard, okay, with the notes I prepared. Before that, please subscribe my channel, textile channel, fashion channel, mathematics channel, that is Veeranna tutorials. Those who are not yet subscribed yet, please subscribe. Please share to your friends and click the icon bell for the notifications you receive for my future videos. Okay, please watch. In this video clip, I'm what I done notes on reactive dyes. See, reactive dyes. This dye is a most popular and versatile dyes in nowadays. Not nowadays, already many years completed. This is a popular dyes replaced the direct dyes, bad dyes and other local dyes. See, reactive dyes, the name itself indicating this dye molecule is reacting with the dipolymer chain. See, already in the notes I given how this reactive dye, here first one chemistry is there. What is chemistry of reactive dyes? Reactive dye is having the reactive group. That reactive group is reacting with the polymer of the fiber chain permanently. Whatever reaction takes place, after reaction, the dye becomes an integral part of the fiber. You see, in other dyes, some other dyes, the fibers absorb dye particles but on the surface. Even the dye particles enter into the amorphous region of the fiber, but those entered dye particles not reacting with the polymer chains, that is chemical substrate of the polymers or fibers, but that is temporary. That is direct dyes, bad dyes and other local dyes, acid dyes, base dyes, so many dyes are there, modern dyes, sulfur dyes. This is a special case, reactive dyes. Dye became integral part of the fiber. Then think about the fastness, think about the light fastness, think about the rubbing fastness, think about the wash fastness. Definitely it's good. If the dye particle, if the color particle is become in permanent relation with the fiber, then there where the question of fastness or bleeding of the colors or rubbing out of the colors. Nothing. Why it is versatile? Why it is famous? Why it is popular reactive dyes? Because of this. The reactive group or the molecule, I'll come to the part for the reactive groups, for other things now. The reactive group present in the reactive dye react with the fiber molecule by means of covalent bond. You heard in chemistry the covalent bond. Okay? By making a covalent bond, that is permanent bond, it's great. In cellulose fibers, hydroxyl groups will be there. In polyamide, amino groups will be there. That is OH groups, NH2 groups. Okay? This reactive dyes not only a cellulosic fibers, not only cotton fibers, cellulosic fibers. Cellulosic fiber means flax is a cellulosic fibers, linen is a cellulosic fibers, hemp is a cellulosic fibers, cotton is also cellulose fibers. Other than this, reactive dye is used for dyeing wool, protein fibers, wool, and polyamide synthetic fibers, nylon also. Okay, most of the cases, usually nylon acid dye is used, but reactive dyes can be, but protein fibers and cellulose fibers are used. See, covalent bonding, the main reacting between the reactive group and fiber polymer is the main covalent bond. This covalent bond makes the color particle hold the fiber permanently and gives the best fastness. Okay, and other good qualities. See, this reactive dye is applied. There are mechanisms are there in applying the fibers, the dye of the fibers. So many dyeing methods are there. That is exhaust dyeing, continuous dyeing, and semi-continuous dyeing is also there. Okay, what are the mechanisms? That is also one part. And what are the solvents used? What are the solvents used? That is solutions. That is with the high pH or neutral solutions. The pH here, the main content, the main point factor here is the pH is to be maintained. Okay, pH to give the to make the fibers fixation, to make the dye particle fix on the dye, or to perform the reaction well, or the fixation of the dye, the alkali is added. Alkali is required. Alkali, NaCl, sodium chloride, okay, glauber salt, these are the things are there. Those are things added to maintain pH. Sometimes pH, high pH is required to maintain, sometimes low pH is required. Sometimes high temperatures need to be required, maintained, sometimes low temperature need to be maintained, or medium temperature is to be maintained. Depends upon the type of the dyes and type of the shades. What shades is going to be dyed, whether it is darker or medium or light shade, or brighter shade or darkest shade. It depends upon that. The shade, that shade is achieved by controlling the chemical process, the solutions, by adding, by controlling the alkalis, pH, by controlling the pH, increasing the alkali. Okay, that is required. NaCl in the case of the reactive dyes, and also before the absorption of the dyes, to absorb also electrolyte is required. Electrolyte, that is also required. At the time of starting of the mechanism of the dyeing, starting dye to absorb, the fiber has to absorb the color. To increase that absorption, these are the things are required. Glauber salt and other things. That is electrolyte. The electrolyte makes the neutralization. And pH, that is hydroxyl group, NH2 group, making covalent bond, alkali is added. And wash off, hot wash, cold wash, and soap wash. Okay, what the mechanism is there? That is industrial process to dye. Okay, and it comes to here, compared to direct dyes or acid dyes, in this is the structure is there, chemical structure. This is one example. Many structures are there. In reactive dyes, this is one example. The structure. These are the benzene rings are there. Here, what are the OH group, NH? These are all the bondings are there. Okay, this is the dye, reactive dye. This is having the bridge NH group bridge is there. See, I am for the in many books they have written something just for your information. Just I am writing general structure of the reactive dyes. If it's CBR, somebody are writing DBGX, somebody are writing RBX. So I am writing CBR. It is the first word of the process. What is taking place in the reactive dye? What is there? Reactive C means chromogen or chromophore. In reactive dyes, this is one part of the reactive dye. This chromogen or chromophore. Chromogen is a color producing part, substrate. The color, the cause to produce color, blue, yellow, red, or whatever the color is there, that color making part in the reactive dye, that is part is chromogen or chromophore, we call this. That group will be there. And second group, which one is available in the second group is bridging group. Bridging group means the dye as well as reactive group. This is the reactive group. Bridging means NH will be there. NH, this is bridging group will be there. This is sodium sulfide, NaSO3. Sodium sulfide. Sodium sulfide, NaSO3. This is what you call. Before that I am telling you, this structure is for the red color, reactive red 1. The color, the commercial name of this color is reactive red 1. For red color reactive dyes, this is structure is there. Sodium sulfide, this is the sodium sulfide chain is there. Polymer chain is there, structure is there. In that OH group is there. HN bridging HN is there. That is HN is the bridging group. This will be amine, ethyl, methyl, oxide, sulfide, whatever group. It depends on the color to color. It will change. In this case, NH is there. NH is the bridging group. And another thing is Ci is there. Cl. This is not Cl. That is chloride. Chloride part is there. This chloride part is a reactive group. This total, this part is there. No, this is a reactive group. This group is reacting with the fiber. This whole the structure of the reactive dyes. In that, this part is there. No, this part is reactive group. This whatever this dye part, this color making part, this sodium sulfide, whatever this chain is there. No, this making chain, this polymer chain. What we call in our study, we study as benzene ring. Like that we have studied. Whatever you take this part, making part. Okay. See, this part is there. No. This part, this is the color making part. This is the color making part, chromogen, and this is the reactive group, and this is the this NH, this making the bridging group. Okay, color group, bridging group, reactive group. These three parts are there in any reactive structure, chemical structures. Please understand. Okay, that will be, but chemical will be changed. In this case, reactive red color, sodium sulfide is there, NH group is there, and Cl group is there. Okay, but in other case, bromine, in case instead of Cl, bromine will be there, or ethyl will be there, oxide will be there. It will change. Okay, and one more point in this reactive dye is that most reactive dyes, this color part is there, this color part. This color part of the reactive dye may change. It may be azo dye, it may be azo or anthraquinone or phthalocyanine or metal complex. Colors are made by azo or by anthraquinone or by phthalocyanine or metal complex. These are things like that. But study is saying that most of the reactive dyes are made of azo dyes. Made of means there are azo dyes. The color content of the reactive dye, most of the colors are of azo dyes. Okay. This is a simple brief explanation I am giving you. And commercially, the name of the commercial reactive dye is we can say Ramazan. This is a commercial name. Procyon is a commercial. Sevacron, Levafex, reactone, primogene, like that. Still more are there. These are the commercial trade names. What commercial trade name? Ramazon, red, blue, yellow, Levafex, red, blue, Procyon, red, and also along with the Ramazon they are writing color name blue, yellow, or red. Along with that, what they are writing now? If it is the reactive group is containing Cl chloride, they will write Cl, or it is bromide, bromine, like that. The name will come. That is commercial. That is not required. This is a class not for commercial class, commercially industrial print. This is the educational class. You can, if you want, you can refer books and other source. Okay, these are commercial names. And groups, reactive groups. What is this part of the reactive group? That reactive groups are of three types: triazine group, pyridimine group, reactivedyes. Okay, these are all totally, these are all the halogen. This is halogen part. Halogen type of halogen group that is containing Cl chloride. For the Cl is this type of. Whatever the structures are there, whatever reactive dyes are having Cl chlorine, that is halogen. Those are having these three types of group: triazine group, pyridimine group, reactivedyes. Okay, they are having, and also derivatives. These are halogen derivatives of nitrogen contain heterocycle. That's heterocycle. That is a chemical name. This is part of the groups containing. They are called C. This is a heterocycle. Heterocycle. I am writing here with the black for your understanding. Please pause the video and take the notes. Pause the videos and note down. This is a heterocycle. Okay, heterocycle. Okay, this is the reactive group. This is a reactive group. Just I am writing for your information. This is a bridging group. Okay, just I am mentioning and I am recording in the video. That's for your information. Okay, then this is the color part. Chromosome. Okay, this is about the structure of the reactive dyes. Now, see about reactive dyes making covalent bond with the fibers, and also the solution pH may increase or decrease. It may be neutral. Sometimes the dyes are processed, dyes are done in the neutral way, or sometimes increasing the alkali is required. These are required variation to make process variation is required in the process. Okay, so high pH is also required. See, I am coming to the pH. There are two classes of reactive dyes are there. One is low reactivity dyes and high reactivity dyes. Low reactivity dyes and high reactivity dyes. See, in reactive dyes there are three classes are there. Three classes are made based on the reactivity, the capability to react. Say, ability to react with the fiber. Low reactivity means that is, it's not efficient. Immediately it will not react with the fibers and get colored. Okay, it will take time, or it is inefficient, that we call this low reactive in nature. Some dyes are low reactive in nature. Okay, in that case what to do? In that case, if it is a low reactive in nature, then pH of the solution to be maintained is 11 to 12 pH to be maintained. 11 to 12 pH is to be maintained, and Na2CO3 sodium carbonate, Na2CO3 is required. That is alkali to be added. So Na2CO3 sodium carbonate alkali is required for the fixation, and pH 11 to 12 is required for absorption fixation. These are the process for case of low reactivity dyes. But what temperature, how much temperature required? 60 to 90 degrees centigrade temperature is required. High temperature is required. That is the reason these reactive dyes are called hot band reactive dyes. One way these are called hot band reactive dyes, 60 to 90 degrees centigrade, and pH 11 to 12. Use sodium carbonate, Na2CO3. These are low reactive in nature. To increase the reactivity, temperature is required, alkalization is required. And comes the second part, high reactive, very efficient in nature reactive dyes. For them, pH is required, less pH is okay, 10 to 11 is okay. And same NaH, sodium hydrogen carbonate, NaH, sodium hydrogen carbonate, NaH is there, sodium hydrogen carbonate is there. Okay, NaHCO3 is required. And temperature required is less temperature is 25 to 50 degrees centigrade temperature is required. So less temperature for high reactive in nature dyes, less temperature is required, less pH is required. For low reactive dyes, high temperature is required, high pH is required. But the dyes between low reactivity and high reactivity, that is to be managed between these temperature, that will be 40 to 60 degrees centigrade or 10 to 12, whatever medium is required, that is to be maintained. Those are called medium brand. Hot brand, cold brand, medium brand reactive dyes. This is one class of dyes. Low brand, low reactivity, high reactivity, medium reactivity. This is one class of dyes. And based on the reactive groups, Cl groups, bromine groups, SH group, OCH group, triazine group, pyrimidine group, oxygen, quinoxalane groups. Like this classification is done based on brand, based on temperature, based on groups, whatever it will be classified. These are all, whatever the brand or whatever the reactivity, whatever the group, the commercial names are, these are commercial names. Ramazon, Procyon, Sivam, these are the trade names of the specific company, dye making company of Switzerland and other countries are there that I have not written here. You can refer, if you require, if you refer. Just this is an educational, I am giving educational part. Okay, hope you understand all the reactive dyes. And here one more, I think, hope we have it seems or not. Here this is the chemical reactions takes place. How the covalent bond takes place. How the covalent bond, the reactive dyes, how it reacts with the fiber. See, D is there. D means this is the dye. SO2, CS2, NaSO3, sodium sulfide, CS2, this is a polymer chain. This totally it is a not polymer chain. This is a dye. This is a dye particle. Whatever the reactive dye chain, what you call, this is a structure. Sodium sulfide is there, CS2, this is a ring is there, SO2 is there. This is when it's react with OH, cellulose. Cellulose means cotton. Cellulose means OH. OH group, that is hydroxyl group, is available in cellulosic fibers. Okay, this dye is react with OH group, hydroxyl group, making covalent bond and giving here DSO2, CS2, O cellulose plus NaHCO3. This hydroxyl group, okay, the H hydrogen bond, this H is added with the NaSO3. Sodium sulfide NaSO3 is become sodium hydrogen sulfide. Okay, this is reaction. This is for cellulose. Below there is same reaction, that is for coal. Please note down. Please pause the video. You can see now. You can pause. Please pause the video and note down. Okay. See, this is about the what you call reactive dyes. Then, what are the fibers this reactive dye is used to dye? Cellulose fibers, already told, cotton, rayon, viscose, flax, hemp, cellulosic fibers, that reactive is okay. Then polyamide fibers. Polyamide means nylon, that is dyed with the reactive dyed. Protein fibers means wool is a protein fiber. Silk is also a protein fibers, those can be dyed, and nylon also. Acetate fibers also dyed with the reactive dyes. Okay, these are the things about the fibers. Now, what are the benefits are there if we dye with the reactive dye? Complete color range, wide range, means any color, any shades can be dyed is possible with the reactive dyes. High bright can be dyed, high pale colors can be dyed, heavy dark colors can be dyed, medium colors, any kind of shades, many options of shades can be achieved with the reactive dyes. And what are the other benefits are there? Easily applied. It's not a complexity in applying the reactive dyes. It's very easy to apply, and it's not any complex in nature and time consuming. Nothing. It is not a time consuming. It is usual time. 60 to 90 minutes is required. What is the time? 60 to 90 minutes is required to dye reactive dyes. And price is also, cost of dyeing is also very less compared to other things. Cheap price. Dyeing process is very cheap. Okay, it's not. And also brilliant shades can be achieved. Brilliant shades achieved, and versatility is more versatile. Okay, very demanding. Versatile is a cheap price. Okay, these are the benefits are there. What are the dyeing methods used to dye the reactive? Exhaust dyeing. Okay, continuous dyeing, semi-continuous dyeing. These are the dyeing methods. Okay, exhaust dyeing. Okay, exhaust dyeing. See, in exhaust dyeing, the color is required. Earlier explained dye absorption, fixation, wash off means after dye absorption, fixation is done. After color, once the dye is completed, the fabric or fiber, whatever textile material is dyed, that is taken out. First wash with hot wash, next cold wash, and with soap wash. Why is it required? Not only this washing, striping is also required. Striping. Once the dye is done, fabric is striped, because to achieve the dye level. Sometimes colors are there is what you call the level is there is a variation in the level of dye will be there. Thick and thin parts of the fabric. Some very dark will be there, some very light will be there. So stripping is done to achieve the dyeing level, and wash it first with the hot wash is done. If you are unwanted or some colors are pasted or stick to the surface of the textile material, that is to remove that. Hot wash, cold wash, and soap wash, totally to remove the unwanted color placed on the textile materials. Okay, these are things are there. Next, what are the goodness of this reactive dyes? Why we have to go for reactive dyes? Means properties or other things. Why we have to go for reactive dyes? It is soluble in water. Reactive dyes are soluble in water. Okay, easily soluble in water. Even the reactive dyes available in powder form, paste form, and dye form. Even you can purchase reactive dyes in powder form and mix in a water solution. It will be soluble. Okay, so easily soluble. So because of easily soluble, it is very simple to apply reactive dyes. Okay, and this is a kind of anionic dyes. There are dyes are there. You heard this dyes, cationic dyes, anionic dyes. Means because this anion and cationic in nature dyes are required, electrolytic in applications. Okay, that is the other part of the chemistry. These are called, just I am saying, anionic dyes. And exhaust dyeing. Exhaust dyeing can be done by exhausting. This color can be achieved. And to achieve shades, different shades, heat variation is required, heat application is required. Earlier I told, sometimes to achieve the change, the final shade of the color, temperature application is required, heat application is required. How much heat is required for the solution to achieve that shade, particular shade? For to achieve particular shade, particular deftness of the color, the temperature is required, heat application is required. That is possible in reactive dyes. And all I told, reactive dye is available in powder form, liquid form and paste form. And most other advantage here is the good light fastness. The fabrics of textile materials dyed with reactive dyes possess very good, excellent light fastness. That is, if the textile material exposed for prolonged exposure to sunlight, ultraviolet cannot do anything, cannot harm, and also the fastness, there is no changes in the shades. The excellent means up to 6, the grade in the testing lab, the grading is there, no fastest grading. This is 4 to 5 is a good one, excellent. 4 to 5 itself a good, 5 is excellent, but this is 6. Light fastness of the reactive dyes is when 6, up to 6 it will come. Wash fastness 4 to 5 is there. Even for laundry, home laundry or consumer laundry, hand wash or machine wash, whatever laundry, wash fastness is good. And also rubbing, cracking fastness, that is moderate rubbing, that is not a bad. Even for direct dyes, acid dyes and other dyes, rubbing fastness will be very less, especially in dark colors. But here moderate means not too bad, not too excellent, good fastness. For dark colors, usually for black or dark navy or dark blue, it will be there. For rubbing fastness will be less, will be there, moderate will be there. And also the industrial process for dyeing, pad batch method can be used, pad drying method, pad strain method, and this continuous, semi-continuous, exhaust. These are all the possibilities are there. There is no limitations in the laboratory or in the industry for application of the reactive dyes. Okay, and other than this, dye, not only dyeing, even printing of fabrics, good printings, that is direct printing, resist printing, discharge printing, and even inkjet printing, reactive dyes, reactive colors are used. Okay, many applications are there. This is a popular, the reactive dyes are very popular. The commercially, it is very worldwide, reactive dyes are appreciated and it is worth in terms of price, in terms of quality, in terms of efficiency, in terms of fastness, okay, and also in terms of performance and economy. Hope you have understood on reactive dyes. This is not in detail studies, this is an introduction part what I gave. You can read the books on dyes and refer any other sources like web articles and journals and other things. Okay, once again I am saying you, please subscribe my channel. Those who are not yet subscribed, please share it, wave it, like it, and click the icon bell for my notifications in your mobile inbox. Thank you very much.